So, when it comes to rules of logarithms, the first thing we need to understand is what exactly is this function and what are its components. So, n is the power is what we call the power index. I know A-level students might already be aware of this, but these are basics which everyone should recap. And A is the base. So, indices are the rules regarding bases which involve a power. So first of all, let's look into the rules where the bases are the same. Like for example, in this case, when bases are the same but powers are different and there is a multiplication sign in between, we add the powers. Similarly, if the bases are the same, the powers are different but there is a division sign in between, you will subtract the powers. And then, what if our function is something like this, where this function has another power. In this case, we will multiply the powers x into y. And then rule number 4. What if the powers are the same but the bases are not? In such a case, we take the power common and multiply the bases. These rules would eventually become embedded in it, if not yet. And then, what if the powers are the same, the bases are different, and there is a division sign in between? Then we will again take the power common and divide the bases. And then the sixth rule, that is a to the power 0. So anything to the power of 0 is 1. What if we have 1 to any random power? Let's say infinity. It would still be 1. 1 to any power is 1. Rule number 8, a to the power 1. Anything to the power 1 is always the thing itself. Let's make a column for neat and tidy. Alright. Let's say let's change the color to rule number 9. What if I have 0 to the power x? 0 to any power will always be 0. Then what if I have 0 to the power 0? What would this be? So one rule says that 0 to any power is 0. Whereas the other rule says that anything to the power 0 is 1. So a, this is undefined essentially first of all, and we'll write this down why. Because we have one rule which says that anything to the power 0 is 1, and we have another rule which says 0 to any power is always 0. And the examiner won't usually ask you, but you should know it's undefined. Then rule number 11, anything to a negative power, if reciprocated, the power would turn positive. And then 12, rule number 2, what if we have a fractional power? In this case, we can write this like this. Root x and then like for example, if I have the square root of a, that's it. So this can be written as a to the power half. Similarly, cube root of a can be written as 1 to the power. And then 13, a to the power y over x can be written as, it's important to distinguish between these two rules. So something like this. And for your ease, you can also include brackets, but that will not affect the answer. And then rule number 40. What if the powers are the same, the bases are different, and there is an equals to sign in between? This is a bit different from these rules, so I write this down with a different color. Let's say pink. So in this case, the powers are the same and the bases are different. In such a case, we will cancel out the powers and equate the bases. Similarly, what if we have the same bases but different powers? In such a case, we'll cancel out the bases and equate the powers. So, these are the rules of indices. Let's take a few examples. Like, for example, the first example could be something like 2 to the power x is equals to 8. So, since we haven't covered rules of logarithms till now, the way you can solve this is writing x in the simplest form, that is 2 cubed. Then we can use this rule that the powers and that the bases are the same and we can equate the powers. Thus, x is equals to 3. Then, what if we have e.g. example 2 is 2x to the power 2x is equals to 5. So we cannot write 5 in any form which is simpler than 5. Thus, we must use logarithm. Whenever an equation is such that the rules of indices fail to give an answer, we need to apply the rules of logs. And this is where logarithms come in. So, logarithms essentially look something like this. And what are they, if you don't know? So, logarithms essentially is something like in this case, we read this as what power should 2 be raised to, what power should 2 be raised to, so we get a 5. If you read it like this, you'll never make a mistake. And if we what power should 2 be raised to, so we get a 5. So we can write this as log base 2 to 5 and is equal to x to find the power. So let's move on to the rules of logarithms. Log base a, wait, I made a mistake here. This should be b and this should be c. Alright. So in this case, we are adding logs with the same base but different powers. In such a case, we will take log with the base common and multiply the power. For example, here we take log base 2 common and then multiply the powers. This turns out to be log 2 to the power 15. And then you can use a calculator function to find out. Then what if we have this? In such a case, we will take log base 7 common and multiply 5 with 4. This will give log base 7 to the power 20. And the second rule. What if logs with the same base but different powers are subtracted? Then we will take log with its base common and divide the powers. Like, let's just say, for example, I have log base 3 minus log base 3 to the power 2. So I'll take log base 3 common and then divide the powers. This will give me log 39, and we know that if 3 is raised to the power 2, we get a 9. Thus the answer is 2. And then we move on. Rule number 3. If a log with a base and a power is such that the power has another power. The power has another power. Then we multiply the power of the log with the log function. That is, we take this power of the log here and multiply this with the log function. For example, in this case, we can take 5 there, and this would become 5 in multiplied by log base 2 to 3. The answer would remain unaffected. The, the rules mean that the answer would remain unaffected, and therefore the rules exist. Math will never contradict with knowledge. That's the good part about math. You need not show the arrows, so let's do this thing without arrows, and this would turn out to be this. And you guys should note that this thing is not equals to this thing, because in this case c is the power of the log, whereas in this case c is the power of the whole log function. The answer provided by this is not the answer provided by this, and this is because when the power has another power, we solve this first and then plug this whole thing in the calculator. Whereas in this case, we will plug this whole thing in the calculator first and then put the answer to a power. Then what if, and then rule 4 is the reverse of rule number 3. That is, anything multiplied with the log function becomes the power of the power. For example, in this case, 2 would become the power of 3. And this would give us log base 2, 3 to the power 2, and we can further simplify this and get log 2 to the base log 2 to the power 9. And then we have rule number 5, which is similar to the two rules which preceded it, rule number 3 and 4. So in this case, if the base has a power, then the power would then the log function is divided by the power. Read that again. If the base has a power, if the base has a power, the log function is divided by the power. And thus, let's solve a few examples again, yet again. So this can be written as this. The power of the base becomes the denominator. And in this case, we'll have log base 5 to the power 11 divided by 2. The whole thing is divided by 2. And then once again note that these three rules are not equal. These three things are not equal rather. Then we have rule number 6. When the base and the power are both the same, then the log function would give the answer of 1. It would always give the answer of 1 because log with the same base and power is 1. In this case, the answer is 1. In this case, the answer is also 1. In this case, the answer is also 1. Then rule number 7. Rules start getting a bit simpler. Log with any base and power of 1 is 0. What power should 2 be raised to give 1? 0. What power should 8 be raised to give 1? 0. What power should 5 be raised to give 1? Is equals to 0. Why is this so? Because we learned in rules of indices that anything to the power anything to the power 0 is 1. And thus, we have this rule. Then rule number 8. Log a, log base a to the power of 0 is undefined. The power of the log function can never be 0 or negative. And similarly, we have rule number 9. The power of the log function can never be negative, thus it is undefined. Then we have rule number 10. If to solve an equation which you will encounter and you will have to apply this rule, and we feel the need that, let's say, A should be in place of B, and we want to interchange the base and the power, then we'll have to reciprocate the log function. That is, the denominator becomes the numerator and the numerator becomes the denominator. So let's say in this case, we want to interchange the base with the power. So this would become 1 over log base 3 2, and then you want to interchange the base and the powers again, so this will become log base 5 power 7. And then we have rule number 11. That is simple. Lg is simply used to represent log base 10, or in other words, log base 10 can be represented as Lg. Similarly, we have another rule, that is log base e will be represented as ln. These are two things you need to remember for now. And these are two very important concepts. Without these, you might not be able to solve a few questions. Yes. If you don't know what LGS and you don't know what ln is, obviously, how will you solve questions? So in this example, we know Lg is equal to log base 10, and anything with the same base and power is 1. Similarly, in this case, we know that this would be log base 10 to the power 1. You need not expand this in this case. It's very simple. And anything with the power of 1, any log with the power of 1 is 0. Because anything raised to the power 0 is 1. Then we have rule number 12. That is ln is equals to log e. I just explained this. So ln can be written as log e and e will remain as it is. So anything with the same base and power is 1. Anything raised to the power, no, any log with a function with the power 1 is 0, because e raised to the power 0 would also be 1. And we need, whenever we apply logs, it means we need to find the power. Then rule number 13, log if logs with the same base but different powers are equated. If logs with the same base but different powers are equated, we will, in other words, we will cancel the log with their bases and equate the powers. Thus, for example, in this case, log base 2 will cancel out from both sides. We'll get this. Simplifying this would give me this, and x turns out to be 3. In this case, log with no base is assumed to be Lg. Thus, we'll cancel out the logs, and we have 5x minus 3 is equals to 2. This would become 5x is equals to 5 and x becomes 1. How simple can this possibly get? Now for rule number 14 and 15, these are just a sequence of steps. If you want to go through them, you may. But I'll explain this conceptually again. Conversion of logs into indices. I'll just shift this down a bit. Alright. So let's just say for rule number 14, you should understand this concept conceptually again. So this is what we have. What power should 2 be raised to get 5? So in order to find the power, we use logs. What power should 2 be raised to get 5? Use your calculator function and solve this log function, and the answer which you will get would be your answer. I don't have a calculator near, or rather I do, but I just leave it to you to solve it. Then example 2. Let's say I have 3y is equals to 15. We use logs to find the power. So what power should 3 be raised to find 15? You use your calculator function and find the answer. But this is the answer in the exact form. In exact form. Yeah. Then example 3. 5 to the power z, let's say, is 20. Thus z is equals to log base 5 to the power 20. What power should 20 be raised to get what power should 5 be raised to get 20? That's how it's done. Then for rule number 15, how to convert logs into indices. This too is very simple. And if you notice the steps which I had to write for the sake of writing, I just wrote them, but they are the same. But you should try and understand these two rules concept. So for this, let's take an example. Let's just say I have log base 2 to the power 18 is equals to 3. This is solved. So if I were to convert this to indices, I can write this as 2 should be raised to the power of 3, so I get 8. This is how things work. Then rule number 16 is solving logs. You can either solve logs by using this LG in the numerator and denominator, or you can use this formula ln in the numerator and denominator, or you can just simply use your calculator function, which is the most common method. You might be seeing this function on your calculator. Just use this function and then plug in a and b to find the answer. Like for example, in this case, if I were to use the first method, that is using LG, I'd have LG3 over LG2. The answer would be, just a second, 1.585. Alright. Then what if I were to use the second method? ln2 is in the denominator. Okay, so ln3 over ln2, this would give me 1.585. Then what if I were to use the most common method? That is the function in my calculator. This would give me 1.5852. And notice that all three answers are the same. Whatever method you opt for is correct. And thus, we wrap up rules of indices and logs here.